call me Terry, and like she said, I'm a maths and science teacher. So being a teacher, you're not here to listen to me, you are here to participate. And I'm very glad I've attended one of my Partners for Possibility seminars, because I found a great culture of sharing and integration and various schools from different places, and I really enjoyed that. So I hope today I can share a little bit that I know on reflective learning, and definitely I know I will learn a lot from you. So it's not going to be teacher-centered, we're going to focus on our crowd today. All right. So basically what I'm looking at is, I'd just like you to think about maths a little bit, and I'll give you just one question. It won't be long, and it's very short, and 1 minute. All right. So in 1 minute, I hope you haven't seen this before. What would be the correct answer? You get to a McDonald's drive-thru. If you want to scribble, there's some pieces of paper on your chairs. Okay, I think we've got answers. I'm happy to see people are chatting, because that's the next thing. Just talk to the people around you, see what answers they got. Okay. I think people did get different answers. I heard 25. Well done. I heard 60. Well done. I heard 17. Very good. What else? I heard so many different answers. And what I enjoyed the most is that people were trying to explain to each other how they got the answer. Do you know the correct answer? 30. 17. 15. All right, so the correct answer is 15. How? Those who got 15, care to share? Thank you.
Well, you have to, with the bottomless rule, you have to start with multiplication. Therefore, you have to multiply the second and third together and add the first and third.
All right, so
It's multiplication.
So 50, that sounds like
times 2. That's 5. So here's applied bottomless. And the first time I did this, I didn't figure out there were 2 packets of chips. But now this is just 1. So it's 10 times 1 plus 5. Yes.
I think our answer is actually a Happy Meal.
A Happy Meal? I wish I had a Happy Meal today for you. So how many times do we get to a drive-thru and you actually don't know how much you're going to pay? I always ask the attendant, how much am I paying? Because I can't figure it out fast enough when you're buying a meal. So what we actually have done is we have reflected. We have reflected on this experience that we have just gone through. We did realize that there were differences in our working, and we've come up with a correct answer. So reflection is when we look at a process. You step back and look into the situation. I noticed some people were reflecting whilst they were working. Before they shared their answers, they had gotten 2 or 3 different answers already. So they were actively reflecting whilst they were working on the problem. And so this leads us to today's session on reflective learning. Okay, I'll just put a little bit of theory. It's a way of allowing students to step back from their learning experience to help them develop critical thinking skills and improve on future performance by analyzing their experience. This type of learning will help the student move from a surface to deeper learning. It can include a range of activities, including self-review, peer review. So our experience is the McDonald's drive-through. And we hope to improve on future events like this through the analysis which we have done. We have reflected using each other, and so there are different types of reflection. Another definition by Boyd, it's a process of internally examining and exploring an issue of concern triggered by an experience, which creates and clarifies meaning in terms of self and which results in a changed conceptual perspective. It is an issue of concern to me that I couldn't work out this problem the first time round because I was told to do it in 30 seconds. And being a maths teacher, that would be disturbing. I'd expect to know what I should pay when I get to McDonald's. So on reflecting on this issue, I'd like to believe that I have changed my perspective to drive-thrus. So we learn from experience. Everything that you do is an event, but for you to learn about that event, you have to step back and look into the experience in order to gain an understanding. Why should we talk about reflective learning? 75% of what we do is retained compared to 5% of what we hear. So if I just tell you, people make mistakes at drive-thrus, you'd say, oh, okay. But if you actually go through the process, you realize that this does happen. Another example I can think of is when I take my kids home or to the village and there's a nice fire and the baby wants to touch the fire. I'll be like, no, don't get closer to it. But my mom will say, no, let him touch. If he gets burnt, he'll never do it again. So as teachers, as parents, we try to forewarn our students. We try to tell them everything before it happens. Sometimes you need to let them go through the experience, then you take them out of that experience and allow them to reflect on the process. Kolb has a very nice learning cycle whereby the first thing that we normally go through in life is an experience, or in the classroom is an experience. But we then need to reflect on it in order for us to have a deeper understanding. And that is true of mathematics as well. It's easy for the teacher to give an example on the board, show the working. Kids, do you get it? Okay, now try it. Who got the correct answer? Yes, well done. If you didn't get the correct answer, it's 15, and we move on. But that child didn't actively reflect on what happened, why they made a mistake, where they went wrong. So it's important to then process, analyze the experience, and then connect that experience and apply it to other situations. So that when they meet a similar problem, or another problem where they can apply what they've learned, they are better at it. So this is a really big responsibility which maths and science teachers carry. So what we can do in the classroom for our learners is to assist them in the reflection process whilst they are carrying out their mathematical problems, so that's in action, or after the process has occurred. That would be reflecting on the action. It's best with a coach. We are the coaches, and so we are there to teach them how to reflect, because it won't happen naturally. We are there to create the atmosphere, to create a conducive learning environment, so that even when we make mistakes, like we pay 60 Rand instead of 15 Rand, no one will feel that the rest of the class will laugh at them. So as a coach, or as an educator, we can assist learners by using various techniques. Encourage them to develop argumentation skills. Support students to explain and articulate their thinking. They have to think about how they are thinking. Metacognition. If they don't know how they are thinking, they cannot change their thinking, and that thinking may be wrong. We need to make them realize that. We need to engage students in evaluating different methods and strategies. Most of us did not think about BODMAS. But if we can have that discussion where we can compare answers, contrast solutions, probe student thinking. Hopefully we will reach the desired outcome. Allow for individual thinking time. Do we have thinking time if we're in a drive-thru? The car behind you is hooting, maybe, because you're taking so long. The kids are screaming in the backseat, happy meal, happy meal. There's no time to think. But in the classroom, let's give our learners thinking time. Because it's through thinking time that they realize, oh, there may be another way to do this. Let me try it again. I must think about my processes. You can ask them key questions that can trigger reflection on an action. How did you get that answer? How do you know it is correct? What can you do differently? Are there other steps involved? What is the same in this problem and another problem we once did in class? All of these are key questions that we can use to assist our learners. So, if we look back at the original slide, if you were a learner, would you have thought of another way to answer that question if no one else had assisted you? If we didn't share our answers, if we didn't give ourselves that opportunity to think and reflect, would you have gotten to the correct answer? Now, as an educator, do you think I presented this problem in a way that encourages reflection? If I tell you it's 30 seconds, go. I don't know. If I ask you to share the answers afterwards, that would encourage reflection. So we as teachers also need to reflect on the learning process for ourselves as an educator, not just the reflection which is to be done by learners. Okay, so as I said, I am both a maths and science teacher. I'm very passionate about science. Now this slide is, I came across an author, Odafe, who has a different way of reflecting in the classroom, whereby we need to develop a habit in our classroom where we ask learners to self-assess themselves. Before they come into a classroom, what are their thoughts? During an activity, what are their thoughts? And after an exercise, they then give a presentation. So the way one of the gentlemen gave us an answer, that's his way of making a presentation on the problem. Hopefully he won't forget this experience because he stood up and explained it. But if you don't give learners a chance to make an oral presentation, to prepare answers, they may easily forget what they have learned. Okay, so now in the science classroom, it's happy. Everyone wants to touch, to taste. It's an environment where you can do almost anything, hands-on and minds-on. I think it's easier to allow for reflection in a science classroom, although unfortunately our textbooks, as I have found in the little research I've done, don't actually guide teachers on how to encourage reflection in science. So it's up to us to introduce them to the reflection process. There are several ways we can do that, whether it's the teacher giving a demonstration, or it's the learners doing a guided recipe experiment, when the learners write up the experiments, or when the learners do projects. So basically I'm looking at scientific inquiry and how we can use that to promote reflective learning in science, so that we can obviously improve conceptual understanding. I've used this in my classroom before. I asked my learners, can I burn a metal? And they say, no ways. Oh yes, you can, ma'am. Oh, you can melt gold and smelt it. And I say, but can you burn it? Can it catch on a light and burn? So I will do a demonstration. I know some theorists say teacher demonstrations are not the best, it's the teacher doing everything. But you can use that to your advantage, involve the learners, ask them to predict what will happen if you burn a metal. I then show them magnesium, which actually does burn with a dazzling white flame. And then I ask them to explain what has happened. This is the POE. Predict what will happen, make an observation, and then explain. So it is in that explanation process where reflection will take place of what has happened. Reflect on the learner's original ideas. Explain why magnesium will burn. It's actually an oxidation reaction. Not that it burns, it's reacting with oxygen. Then you can bring in your concepts, your theories. So you're tying it in with your demonstration. So I don't find anything wrong with teacher demonstrations. I think they're good if they're used in the right way. Guided experiments, when learners have to follow a stepwise recipe on how to answer a question. Say, for example, I asked my learners, what factors affect the rate of dissolving a flu medicine, or Corenza C, or Eno, something like that. I give them the steps of what they should do. They try out the different methods. But when they write their own conclusions, when they explain their findings, allow them to reflect on the process that they have undergone. So I'm sure we are all doing reflection in our classrooms, but we're just not cognizant that we're doing it. So my hope today is that we can actually realize that we do reflect all the time. We just need to make it a habit in our classrooms. Experimental write-ups is another good opportunity for reflective learning to take place in science. Even if you do assist your learners to come up with an aim, assist them to come up with a hypothesis, write out the method for them, allow them to make their own observations. Allow them to draw up their own conclusion. It's in drawing up the conclusion that they have to think about what they have seen or think about what they have done, and that is a reflection on an action. So I find this to be extremely beneficial as well. At my school, we encourage projects and expos. There are various expos which are sponsored by different organizations, ESCOM, for example. And this is one of the best ways to allow students to undergo discovery learning, inquiry-based learning, and they reflect on their own with maybe the assistance of a coach or a facilitator. Learners pose an investigative question. It can be a topic on the curriculum, so you can use this for marks if you want to. It can be on anything that's not on the curriculum, because the curriculum narrows the learners. Some learners have really good, brilliant ideas, which we as teachers don't even come up with. So I allow them to come up with their own investigative question. The learners come up with a hypothesis. So they are taking their own background knowledge, what they think would happen in their investigative question. So they're taking their own prior knowledge. Allow them to use trial and error to discover information. So they can do their experiments at home, in the classroom, or in the lab. They'll try one way. If it doesn't work, allow them to try another and explain why it didn't work. They are reflecting in action. They won't forget things like science expos and projects because they have done it on their own. They've undergone the experience. They have to take decisions. They have to revisit their questions. They have to redo. They have to analyze. They question, they seek assistance. And that's the essence of science. It's not all nice, tailor-made. People have to go through processes. Scientists have to question each other. When they analyze, draw their conclusions and present their findings, just then being able to make a presentation to the rest of the class of how they realized their data is in itself a reflective process. So that's the approach I would take in a science lesson. So in conclusion, reflective learning is basically allow experiences to move into understanding. And it's up to us, the educators, to bring our students, our learners into that space. It doesn't happen automatically, and we have to harness that. Allow them to step back and look into a process. hopefully this can solve one, if not two, problematic issues in maths and science in South Africa, and allow our children to be better thinkers, because that's what we need in society.